What's up, Bacha Party? This is Ankit from EcoSikho, and I'm back with another video on our Math AI syllabus. And in this video number 3, we are going to discuss about quadratic functions. So I hope you have checked out the video number 1 and video number 2, where we had discussed about the what is a quadratic function. We had discussed about how the quadratic function results into a parabola in a graph. We talked about different types of quadratic functions, and let's move on. And in this video, let's talk about discriminant. Okay. So let's say I have been given a quadratic equation in a general form. And the general form looks like ax square plus bx plus c is equals to 0. So in this particular general form, if I have to define a discriminant, which mathematically is written as the triangle symbol, or it is the sign of change, or the delta sign. Okay. So the discriminant can be defined as b square minus 4ac. So this discriminant that we have just defined is a very important concept when we talk about quadratic function. It is considered as an important concept because of the fact that it helps me to determine if the parabola is cutting the x-axis or not. So what I can say is that this discriminant tells me about the relationship between the graph of a function and the x-axis. So if it so occurs that the value of discriminant is greater than 0, in that case we can say that the parabola cuts the x-axis twice. If the value of discriminant is equals to 0, then we can say that the parabola is tangent to the x-axis. And if the value of discriminant becomes negative, then we can say that it doesn't intersect the x-axis. Now, this particular part, the third one, where we talk about the value of discriminant being negative, there can be two further cases here. So the first further case here is the value of discriminant is negative and a, which is the coefficient of x square, is positive. Then this results in a shape, something known as a positive definite. Let me give you an example. So let's say this is my Cartesian plane. So the parabola that I'll be getting will be something like this. Since your A is positive, so whenever A is positive, you get a parabola which is upward concave. And similarly, if the value of discriminant is still negative and A becomes negative as well, then you get something known as a negative definite. Which in the above case looks something like this. Now that we are clear with what is a positive definite, what is a negative definite, how does discriminant tells us about the relationship between the graph and the x-axis, let us look at a few questions. So question number 1, I have been given a function that looks like y is equals to x squared minus 2x minus 3. And based on this information, I have to tell if the graph will cut the x-axis or not. So what I need to check? I need to check the discriminant. So the discriminant is b square minus 4ac. And before you proceed on doing this question, you should be clear with what is a, what is b, and what is c. So in this question, your a is 1, your b is minus 2, and your c is minus 3. So b square will be minus 2 whole raised to the power 2 minus 4 times 1 times minus 3. So that gives you 4 plus 12, that is equals to 16. And since the value of discriminant over here is positive, we can conclude that it is cutting the x-axis twice. If I have an equation of the form y is equals to x squared minus 2x plus 1, then I should be clear that here a is 1, b is minus 2, and c is plus 1. And based on this information, I can proceed to calculate the discriminant, which will be b square, which is minus 2 whole raised to the power 2 minus 4 times 1 times 1. So that's 4 minus 4, which is 0. And since your discriminant is 0, it will be tangent to the x-axis. And if you're still confused, what do I mean by tangency? Tangency means that the graph will touch the x-axis only once. And moving on to the third example, let's say if I have been given y is equals to x square minus 2x plus 3, then here I can see that a is equals to 1, b is equals to minus 2, and c is equals to plus 3. And the value of discriminant will be b square minus 2 whole raised to the power 2 minus 4 times 1 times 3. So that's your 4 minus 12, that's negative of 8. So the graph will not touch the x-axis. Okay, so I hope that was clear. Let us move on to a question number 4. Is equals to negative of 2x squared plus 5x plus 1. And I need to comment about the discriminant. So let's move on. So over here, I can clearly see that A is negative of 2, B is 5, and C is 1, which is 5's whole raised to the power 2 minus 4 times minus 2 times 1. That gives me 12 equals to 33. Since the value of the determinant is greater than 0, then I can finally conclude here that the graph will cut the x-axis twice. And also, if I look closely, the value of determinant is greater than 0 and the value of A is less than 0. So based on these two informations, I can clearly say that the quadratic is neither positive definite, it is nor negative definite. You will think about positive definite or negative definite only if the value of determinant is less than 0. For example, in question number 3, I could have, like, we clearly found out that the value of determinant is negative. Let us look at the value of A. And since over here the value of A is greater than 0, then we can say that this curve will be positive definite. For question number 3, the graph that we will be getting will be positive definite. It will not touch the x-axis and it will be concave upwards. So I hope that was clear. So that's all for this video. I will see you in the next one. And in the next video, we'll be talking about how can we find a quadratic from its graph. We will be given a graph and we'll try to find the equation of the quadratic function using its graph. And yeah, that's all for now. I'll see you soon. Thank you so much, everyone.